Question 6. A sample data consists of the salary for individuals employed in inside and outside sales positions. The sample data consists of 36 observations, which 20 of them are inside and 16 of them are outside. And we have a whole bunch of questions to answer here, so this is a big one. I've already gone ahead and entered all of the inside numbers into list 2 on my calculator and all of the outside numbers into list 3 on my calculator. So we'll be using those when we're answering these questions. So question 1 says to develop a confidence interval, a 95% confidence interval for the mean salary for inside salespersons. So that's using list 2. This is a pretty basic one. I'm just going to go interval T. Why is it T and not Z? Because we've just got a list, right? Whenever you have a population standard deviation, you can do Z. But if you only have a sample standard deviation, or if you only have the raw list of data, you're going to be doing T. So we're doing interval T, one sample, and put in list mode. Confidence level is 0.95, 95%. And list is list 2. That's where we stored our inside salesperson's data. And so we get our confidence interval, which we can just make a little note of here, right, which is from $53,449, if we're rounding to the nearest dollar, up to $57,336. So $53,449. Up to $57,336. And that's part 1. That's for inside. And then part 2 is just we do the exact same thing for outside. And so it's going to be the same process. All we do is change this from list 2 to list 3, because that's where we stored our outside salesperson data. And so we get 69586. Up to 78414. All right, so we're 95% confident that inside salespeople make an average somewhere in between these two numbers, and that the average for outside salespeople is somewhere in between those two numbers. Okay, that's the parts 1 and 2. Now for part 3, estimate the 93% confidence interval for the proportion of all inside employees whose salary exceed 60,000. So this is a proportions question. So we're going to do on the calculator interval Z 1P. And the confidence level is 93%, so 0.93. Then we need X and N. Well, the N is 20 because there are 20 inside people. What's the X? We need to count. Right? How many of these 20 inside salespeople had a salary exceeding 60,000? Well, we just have to count. We got 1, 2, 3. That's it, 3. All right, so 3 out of 20. And we run that and we get our left is very small, 5.33 times 10 to the negative 3. So that's 0.005 to 29.295. Okay, so the population proportion is somewhere, we're 93% confident. The population proportion is somewhere between 0.005 and 0.295. Question 4. Do the sample data suggest that the average salary for all inside salespeople exceed 50,000 using a 0.10 level of significance? Okay, so this is using the inside, so using list 2 again. we're going to write our hypotheses that it exceeds 50,000 versus it does not exceed 50,000. So for question 4 here, we want to know, does the mean exceed 50,000 or does it not? Right, this one has the equal sign, so that's the null hypothesis. And then the exceeds 50,000 is the alternative hypothesis. And then we're going to go and we're going to run our hypothesis test. So we're going to go test T one sample. This is T for the same reason that the confidence intervals was T. We're doing list 2 because that's where our data is for the inside salespeople. And we want to know, does the mean exceed greater than 50,000? We run this and we get a p-value of 6.77 times 10 to the negative 6, right? So that's going to be 0.000000677, right? An extremely small p-value. So that's definitely less than the alpha, which was 0.1 in the question, right? The alpha was 0.1. So when the p-value is less than alpha, we reject the null hypothesis. Right, rejecting the null hypothesis, right? This is our null hypothesis. If we reject this, that means we believe the alternative is true. So we do think that the average salary for inside salespeople exceeds 50,000. And that's our conclusion. Yes, we have enough evidence to say that the mean exceeds 50,000. So that's our part 4. Part 5 is about, is there any significant difference in the variability of salary for outside and inside salespersons using a 0.05 level of significance? This is about variability. So the question is there a difference in the variability? In other words, is the variability as represented by the standard deviations or the variances equal or unequal? So this is the null hypothesis. There's no difference in the variability. And this is the alternative hypothesis. There is a difference in the variability. And if you want to write these in terms of variances instead of standard deviations, you can absolutely do that. Mathematically, it is identical, right? It's the same claim either way. So it doesn't really matter which way you write it. But whichever way you write it, we're talking about an F-test. Because F-test is how you test for differences in variability between two groups. Okay, so then the alpha was 0.05. And we need to get the p-value. So the calculator is going to give us the p-value. We're going to go test F. We're doing lists. We want to know, are they equal or not equal, right? Sigma 1 not equal sigma 2. That's our alternative. And our lists are going to be list 2 and list 3. Those are the two lists for the inside and outside salespeople. And we run that and we get a p-value of 0.0055, right? That's what our p-value is. Which is definitely less than alpha. So that means we reject the null hypothesis. The null hypothesis said that there was not a significant difference. So there is a significant difference. We have enough evidence to say that there is a significant difference between the two variances. And this is important because for our future questions, this means that we're going to be doing an unpooled or a separate variance t-test when we get around to doing a t-test between these two things. Okay, the results of the f-test affect which t-test you do. If you reject the null hypothesis, the variances are different and you don't pool the variances. If you fail to reject the null hypothesis, then the variances are similar. They don't have a significant difference between them and you can pool them. Right, and I think that that's probably what we're going to be asked to do next. Do the sample data suggest that the outside salespersons have a higher average salary than the inside salespersons using a 0.10 level of significance? Right, this is going to be that t-test. It's going to be the independent samples t-test. So part 6, we want to know if the mean for outside is greater than the mean for inside. And that's going to be our alternative. And our null is going to be the opposite. That the outside people do not have a higher salary than the inside people. The alpha is 0.10, they said. And we're just going to test this now. So we're going to go test T2 samples. We want to know using list 2 and list 3. Careful here. List 2 and list 3. We want to make sure everything matches up with how we wrote it over here. So I wrote outside is greater than inside, right? So if I'm writing mean 1 is greater than mean 2, I can do this, but then I need to make sure that my first list is the outside and my second list is the inside. So I would need to make sure this was list 3, the outside people, and this one was list 2, the inside people. The other way I could do it is I could make this a less than, and then this could be list 2 and that could be list 3. Either way would work, right? But you just need to make sure that the order you're putting them in makes sense relative to the order you wrote them in the hypotheses. So I wrote outside greater than inside, so I need to make sure I'm doing outside greater than inside. Pooled is off because of the results of part 5. We rejected the null hypothesis for our f-test, and we don't believe that the two groups have equal variances. So pooled is off. And then we run this and we get our p-value is extremely small. It's practically 0, right? It's 0.000000028. Okay, so p-value is approximately 0, which is definitely less than alpha. So that means we reject the null hypothesis. So we do have enough evidence to conclude that the outside salespeople make more money on average than the inside salespeople, which was kind of obvious from looking at these confidence intervals, right? Looking at the confidence intervals, we already kind of knew the answer was going to be that, yeah, the outside people are being paid more than the inside. Right, that was clear enough already, but we have to do the math, get our results, get our p-value, figure out that we can reject the null hypothesis. All right, and now the last part is part 7. Is there any evidence that the percent of inside employees whose salary exceed 60,000 is lower than the percent of outside employees whose salary exceed 70,000? So this is a percentage or proportions question. Right, so we want to know, does the first proportion that they talk about, is that lower than the second proportion that they talk about? This is our alternative. And then our null hypothesis is that the first proportion is not lower than the second. Okay, so for the first proportion, in our sample, inside employees whose salary exceeds 60,000, we already counted that up when we were doing part 3 here, right? That was 3 out of 20. The second proportion, we're going to need to do some counting again. So this is the proportion of outside employees whose salary exceeds 70,000. So there were 16 total outside employees, right? And then how many of them exceeded 70,000? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? 11 out of 16. Okay, and so then the question is this 11 out of 16 significantly greater than the 3 out of 20? And the answer is kind of obvious. It's going to be yes, right? We can do the calculator and then double check what the calculator says, what is our p-value, but like, it's obviously a big difference. This number is way bigger than that number. Right? It doesn't give us the alpha, so we just assume that alpha equals 0.05. Whenever alpha is not given, that's the default. Okay, so on the calculator, we're going to do test Z 2p, right? It's a two proportions test. And proportions are always Z. So we want to know, is proportion 1 less than proportion 2? Proportion 1 is 3 out of 20. Proportion 2 is 11 out of 16. And we run that and we get our p-value is, like I said, it's very small, right? 0.0005. Which is certainly less than alpha, so we reject the null hypothesis. And we do have enough evidence to say that the proportion of outside employees whose salary exceeds 70,000 is higher than the proportion of inside employees whose salary exceeds 60,000. All right, and so that's our final conclusion for our final part of question 6. And question 6, this is a really good question. You get to run through all the different types of confidence intervals, hypothesis tests, right? We did a one sample test, we did a F test, we did a T test, we did for 2 samples, independent samples. We did a Z test for 2 proportions. The only thing we didn't get to do here is a paired samples test, but we did some practice on those in the previous questions.